but I'm going to just plug it back in up here. So 3 plus 3 times 2 minus 3 minus 2 times 2. What do we have? They're both negative 2? Okay, well, y'all just say something. I've erased it from the board. I don't remember what it was. You're the one who has it written down. Okay, so negative, negative. Wait a minute. Hold on. 1, 4. Oh, yeah, because 1, 4 was up here at this one. Thank you. Okay, so what do you get when you plug in 3, 2? 6, 9. Those 3's cancel. 5? No. 2. You get 2. You get 2. Okay. We've gone around the boundaries, right? The whole boundary we've taken care of. We looked on the inside. We did find a point on the inside. What was that point on the inside? 2, 1? Yeah? So let's put this all together, all right? Let me put all the points that were important to us together up on the board. We had, from the first part of this problem, so I'm on step 3 of this. I'm going to compare now. I have, from the first part of the problem, I got this point 2, 1. From all the different lines, L1, L2, L3, I wound up having these 3 corners. And this one up here, which was 3, 2, right? Does that cover everything? Is that all the points we got? The one here, the 3 corners, and then that 1, 3, 2, 1 right here. Right? That's all of them? Yeah. And now let's just, we already know all their values, right? Let's just write their values down. Oh, we never got, which one did we never get? 2, 1, right? We never got that one? This one was 2, I believe. This was negative 2. This was negative 2. This was 2. Find the value at 2, 1. Plug in 2 for x and 1 for y. 1? All right. That's everything. Now we just need to draw our conclusion. No questions? What is the maximum value of this function on this closed bounded set? 2. The maximum value is 2. Where does it happen? Here and here, right? At 2 places we have the absolute maximum occur. Where does the absolute minimum occur? 2 different places, right? The value is negative 2. So there's different ways we can actually write down this conclusion, right? We can just simply state it, write down all the points. I'm going to kind of show you both ways. The absolute maximum is 2, all right? The absolute minimum is negative 2. Now, if I want to put where they happen, then I could just list the points as ordered triples. I could say 1, 0, 2, and 3, 2, 2. This is where I get my maxes, right? And then I could say, let me see, 5, 0, negative 2, and 1, 4, negative 2. Those are where I get my minimums, right? You should be comfortable stating it either way. The reason why we want to just be able to say what the max is and the min is because a lot of the problems that we would deal with that are like real world or like word problems, that's all we're looking for. And in other problems, you want to know where it happens. And so you would want to know more information like this. OK. Wow, that only took about 40 minutes. May I? I think what we'll do on this one is we'll do all the maths first. After we're done with all the, you ever hear like a lot of Europeans say maths?
Yes.
You heard that? Okay. Yeah. All right. So we're going to do all the maths first. And then after that, we'll compare it with the picture. All right? So we have an absolute maximum, and we're looking for the absolute maximum minimum value of this function. On the rectangle, D is equal to the set of x and y such that x is between 0 and 3 and y is between 0 and 2. So we have to understand what that means first. This is set notation. It's all ordered pairs in two-dimensional space where your x's are bounded between 0 and 3, your y's are bounded between 0 and 2. What does that look like in two-dimensional space? Rectangle? X values are between 0 and 3. So all I know is that the points, the x values have to live between here and here, right? So your x's could be anywhere in here. But your y's have to be between 0 and 2. So it could be anything in here, right? And so what you need is both of them together, which is where they intersect, which is this right there. So we're looking at this rectangular region. It's closed and bounded, right? As long as these inequalities were included the equals, right? Then it includes the boundaries. All right, there's our region. How would you like to go about this? What should we start with? Find the critical points from what we did last class, right? Set the partials equal to 0. All right, so go ahead. Do it. I'll do it up here. I won't say anything. I'll just kind of. I don't like what I did there. Y'all got the partials yet? Set to 0? Got a solution? So your first partial set equal to 0, all you get is the relationship that x has to be y. That doesn't tell you enough. But the other partial equal to 0 tells you x has to be 1. And if x has to be 1 and y has to be x, then y has to be 1. So that's your critical point. Now, we need to double check to make sure. Does it live in here? It does. It lives in there. So check. We will plug that into the function. You want to plug it in now? Just may as well like figure out what the value of the function is now. We don't know if it's a max or min or anything, but let's plug it in. F of 1, 1 will be, is it 1? Yeah. Save that for later. I've had students on tests, the one that you're going to take in class next week, I've had students on tests forget to do this step. They do all the boundary, they move around and all that. They forget to do the partials equal to 0, and I take off a lot of points because this, you have to check that number. I mean, you have to check that point. That could be the highest point, could be the lowest point. If you forget about it, then that's like, It's like forgetting to check one of your endpoints back in Cal 1. You're just like checking part of it, not everything. All right, that part's done, yes? Now, we're going to move around this closed bounded set. So we're going to break it up into how many different pieces here? 4, okay? 4 pieces. So here's what we'll do. Let's define this to be L1, and let's go clockwise. L2, L3, and L4. What I'd like for you to do is let's let these tables right here, these 2 tables, we'll do L1, okay? These 2 tables will do L2. These 2 tables will do L3, and I will do L4, okay? So y'all work out L1, y'all work out L2, y'all work out L3, I do L4. And we'll talk in a second. You do your work, I'll do mine. And y'all can talk to each other.